These are the notes for 1-5, rewriting equations and formulas, otherwise known as literal equations or multivariable equations. Previously, we used the equation that relates the number of quick trips in a minute to the air temperature. Remember that formula was C equals 4 times T minus 148. This allows us to determine the air temperature in degrees Fahrenheit when we know the number of cricket chirps in a minute, or we can also use it in the inverse. We can determine the number of cricket chirps we should hear based on the temperature. So first, let's find the air temperature in degrees Fahrenheit for the given number of chirps in 1 minute. For A, so let's say there are 92 chirps in 1 minute. So that means that C equals 92. We're going to substitute the value of C equals 92 into this formula and determine the temperature. First, we would want to, because we're subtracting 148, we want to add 148 to both sides. (92) plus 148 is 240. So we have 240 equals 4 times t. So the inverse operation to solve would be to divide both sides by 4. So the temperature when we hear 92 chirps in 1 minute would be 60 degrees Fahrenheit. Let's do that again. This time for B, we want to find the temperature when we hear 58 chirps in a minute. So C equals 58. Again, we're using the formula C equals 4 times T minus 148. Substitute the value of C equals 58 into the formula. To solve, we'll add 148 because we're currently subtracting it. 58 plus 148 is 206. So 206 equals 4 times t. To solve, we'll divide both sides by 4. So the temperature when we hear 58 chirps in 1 minute would be 51.5 degrees Fahrenheit. Now, if we look back at those two problems of A and B, 92 chirps and 58 chirps, we used the same steps to solve both problems. First, we added 148, then we divided by 4. Add 148, we then divide by 4. So it may have been easier to first solve the equation in terms of the other variable. For instance, if we had it be temperature equals, and we were able to substitute the value of the chirps, we wouldn't have had to go through the steps for solving. So let's give that a try. Let's rewrite the cricket formula in terms of the temperature T. In other words, we are going to take the formula, the same steps we used to solve T before. We're going to add 148 and divide by 4. And we're going to solve this formula for the variable T. So first, add 148 to both sides. C plus 148 is just C plus 148. So C plus 148 equals 4 times T. To solve, we'll divide both sides by 4. So there are two ways we can express this equation. We can say T equals C plus 148 all divided by 4. Or we can also split that up into two terms and divide C by 4 and 148 by 4. (148) divided by 4 simplifies to 37. So this can be simplified. And now we've reworked that formula. So if we went back and had a number of chirps, we'd be able to just substitute it right in and get the value of the temperature. So let's give that a try. We want to use our new formula to find the air temperature if the cricket makes 20 chirps in a minute. So when C equals 20. The new formula is T equals C divided by 4 plus 37. Or again, you could use T equals C plus 148, all divided by 4. And we're going to substitute the value of C equals 20. (20) divided by 4 is 5. And 5 plus 37 is 42. So when there are 20 chirps in 1 minute, that means the temperature outside is 42 degrees Fahrenheit. Now let's do some practice problems. 1 and 2, we want to rewrite the equation for y. In other words, solve for y. For number 1, to solve for y, right now to the y term, we're adding 4x, so we want to subtract 4x from both sides. I prefer to keep my x term first, but if you'd rather write it as 7 minus 4x, that's also okay. Now to y, we are multiplying y by 9, so we want to divide both sides by 9. You can express your answer like this, or your other option is to divide both terms by 9. So divide this by 9, negative 4x by 9, and 7 by 9. This would be more common if one of those fractions were able to be simplified, but either equation would be correct. The order could also be switched. You could have 7/9 minus 4x over 9. So for number 2, again, we're solving for y. So the first step would be to add 2x to both sides because we're currently subtracting it. Now we have 2 times y. So to solve, we would divide both sides by 2. Now in this case, both 2x and 6 are divisible by 2. So in this case, we do want to think about it split up into 2 terms, just to make sure our answer is simplified. But if you're just able to get to this step, that's great for now, but moving forward, I'd like you to try to simplify. So 2x divided by 2 is 1x, or just x. 6 divided by 2 is 3. So y equals x plus 3. Number 3 is the formula for converting from Celsius to degrees Fahrenheit. we want to use this formula and we want to solve for C. So right now, to the C term, we're adding 32. So the first step to solve would be to subtract 32. F minus 32, it's just F minus 32, equals 9/5 times C. Whenever we have a fraction in front of a variable, the next step is to multiply both sides by the reciprocal. The reciprocal of 9/5 is 5/9. When you write out each step, you're left with the formula solved for the other variable. So C equals 5/9 times F minus 32. Number 4 is the formula for area of a trapezoid. The area of a trapezoid is found by taking 1/2 the height and multiplying that times the sum of the two bases. So we want to rework this formula so that we are able to solve it for h. And we would do that if let's say we know the area, we know base 1, and we know base 2, but we don't know the height. So again, whenever you have a fraction, we always want to eliminate that first. So to eliminate that fraction, we can multiply both sides by 2. 2 times a is 2a, equals height times the sum of base 1 plus base 2. Now this right side here, the height times the sum of base 1 plus base 2, that's just multiplying two numbers together. So to solve, we can divide by the sum of base 1 plus base 2. If you want to use parentheses, you certainly can. Because we've written out each step. Our new formula solved for h is on the left side. So the height of a trapezoid, you can find that by doing 2 times the area divided by the sum of the bases. If a scuba diver starts at sea level, the pressure on the diver at a depth of d feet is given by the formula P equals 64d plus 2,112. Represents the total pressure in pounds per square foot. Suppose the current pressure on a diver is 4,032 pounds per square foot. So we want to rework this formula and solve it for D. So the first step would be to subtract 2,112. P minus 2,112 is just P minus 2,112. This equals 64 times D. So the next step to solve would be to divide both sides by 64. So D equals P minus 2,112 divided by 64. Now, because 64 is a factor of 2,112, it's smart to break this up into two terms. P over 64 minus 112 over 64, and simplify. So D equals P divided by 64 minus 33. So either one of these forms works. This option is a little more simplified. So now, given that the pressure is 4,032 pounds per square foot, we want to find the depth that diver is at. So we're going to use our formula. Substitute the value for the pressure. (4,032) divided by 64 is equal to 63. And 63 minus 33 is 30. So the scuba diver, when the pressure is 4,032 pounds per square foot, the scuba diver is 30 feet below sea level. That concludes the notes for 1-5, solving literal equations, also known as solving multivariable equations, also known as rewriting equations and formulas.